Get ready for a mind-boggling discovery that will make you question the very fabric of the universe. The LIGO-Virgo-KAGRA collaboration has unveiled a remarkable gravitational wave event, GW250114, which has left scientists in awe. This event, observed on January 14, 2025, is a game-changer, offering an incredibly clear signal that has allowed researchers to confirm Stephen Hawking's groundbreaking area theorem of black holes. But here's where it gets controversial. GW250114 is not just a loud signal. It's a fire alarm compared to previous detections. Simona Miller, a Caltech grad student and co-author of the study, describes it as a clear shout amidst the quiet chatter of a dinner party. The signal-to-noise ratio of this detection is an astonishing 80, far surpassing the first detection's ratio of 26. With this unprecedented clarity, the team has measured the areas of the colliding black holes before and after the event. The total surface area of the two parent black holes was a staggering 240,000 square kilometers, roughly the size of Oregon. But after the collision, the final black hole's area increased to approximately 400,000 square kilometers, akin to the size of California. And this is the part most people miss. The increase in area aligns perfectly with Hawking's theory that black holes' entropy, and thus their area, should always increase. However, Hawking also proposed that black holes can radiate and lose mass, leading to a decrease in their area. So, does this mean we've witnessed a black hole defying its own entropy? Professor Vicky Calagera, a leading astrophysicist at LIGO, emphasizes the significance of these measurements, calling them the most precise measurements humans have ever achieved in any field of science and engineering. A second paper published alongside this discovery further explores the potential of gravitational wave observations to test Einstein's theory of general relativity. The authors of the paper write, "The gravitational wave signal GW250114 is a milestone in the decade-long history of gravitational wave science." So what do you think? Is this a step towards a new understanding of the universe, or does it raise more questions than it answers? Share your thoughts in the comments, and let's discuss this fascinating development.